Okay, today, the purpose of today's lesson is we are going to be able to solve our system of linear equations. This time we will be solving using substitution. Now, we should be able to use this method for any two equations. Whereas before with graphing, if we're in between a box, in the middle of a box, we can't eyeball exactly the location of the solution. With substitution, we can find out the exact equation. We can find out the exact solution. So we generally tend to, if given multiple ways to solve it, I would use substitution when I see that one of my variables are alone. That doesn't mean tonight, if none of the variables are alone, that you can't use substitution. It just means it's a little bit more work. Right away, I'm seeing that y equals 2x, right? So I'm going to separate my two equations, write them down, and right away, since I see y equals 2x, y is alone. If y is equivalent to 2x, can't I take that 2x and substitute it in for y? So I'm going to do that. I'm sending it over to the y, and I get x plus 2x. Does everybody understand that? I need to see the arrow moving over and what you're exactly substituting and where you're moving it to. So now I have x plus 2x equals 6. X plus 2x makes 3x equals 6. Divide both sides by 3, and x is equal to 2. Now, if I know my x, can I figure out my y? I go back to either original equation, and I just substitute in. Y equals 2 times 2, right? I'm going to substitute it in for the x, and so y equals 4. So what is the solution to the system? 2, 4. And so your answer should look like this. Put in ordered pair once you figure out your x and your y. Does that make sense? The only time you're really going to use solve by graphing is when given directions. Solve by graphing. Okay? Yes? Can't I subtract x from both sides? Right here? Are you talking about here? Yeah. Well, I could, but why? I've already got a variable alone right here. Y is alone. I don't need to get another variable alone. So I could, and then set them equal. Yeah, you could do that. And then do your substitution, but it's just more work. If something's already alone, I just go with it. Can I move on? Okay, so now you should be able to check. So when you're taking a test, this should work. Y is 4, and this is 2, x is 2. Is this equivalent? And then I'm also going to have 2 plus 4. Is that equivalent? So it's a real easy way to check, okay? The point should work in both equations. All right. When I'm solving something like this, right, I take my y equals x minus 1, and my m is 1, my b is negative 1, and I plot it, and then I'm taking my b is 4, and then I'm going to go down 1 over 3. We don't like to do this graphically because look at the intersection. There's no way for me to estimate what that solution is. So if I'm using substitution, right, can't we substitute x minus 1 for the y? Okay, I'm going to substitute x minus 1. I'm going to substitute it in for that y. And then I distribute. X plus 3x minus 3 equals 12. That makes 4x minus 3 equals 12. I can add 3 to both sides, divide both sides by 4, and we get x equals 3 3/4, or 3 75/100. Now I can substitute it in, and I get y equals 2 75/100. So my solution is 3 75/100, comma 2 75/100. So do you see how I can get exact with substitution? All right, you ready to try this on your own? Now, every time so far, we've been substituting the y because the y was alone. What are you going to substitute this time? You're going to substitute for x 3y because x is alone. Okay, pause the recording and you guys try the next one. Whenever. All right, so now let's check our work. We can substitute 3y in for x. And now I've got negative 10y equals 5. Divide both sides by negative 10. I have a lot of people when they get 5 over 10, they're going, oh, that's 2. No, that's 1/2. 5 divides into 5 once and into 10 twice, so it's negative 1/2. Now, when I have negative 1/2, I can substitute it into the 3y. I can substitute it into either equation, but x equals 3y is much simpler, much easier. Simpler is probably not a word, but. So 3 times the quantity of negative 3 over 2 is negative 3 over 2. Questions? Yes?
I think it's much more simple.
But the terminology. I don't know. Well, we won't debate it now. We'll look at it after class is over, after the recording. Okay. So I should see your answer always in ordered pair form. Okay? Just like this. Questions? Yeah.
Does it matter if it's in a decimal or a fraction?
Nope. Decimals and fractions are the same. All right. So now this time there's a little bit more to it. There's a little bit more to it. This time there's a little more to it. I don't have a variable that is all alone. What is the easiest variable to get alone, to isolate? Jamie?
I would say x.
Yeah, the first equation, the x. So I subtract 2y. And now I'm left with x equals negative 2y plus 5. Now, what can I substitute negative 2y plus 5 for? The x in the other equation. I'm taking it, I'm sending it over here. It's 2 times that quantity. Is everybody understanding? Okay. So now I'd like you guys to finish it up. Okay? Finish it up and solve for x and y. Pause the recording. All right, let's check our work. So we're going to distribute. We get negative 1y when we combine like terms, plus 10. I'm subtracting 10 from both sides, then dividing both sides by 1 or multiplying both sides by negative 1, and we get y equals 3. I can then go back to either original equation, either this one or this one, substitute in that y. Now, it could be the original or the new equation. So aren't these two exactly the same? Right? It's just been reworked. It's still the same value. So I can substitute in here and it makes it nice and easy. Okay, so I'm substituting into x equals 2y, negative 2y plus 5, and we get x equals negative 1, and so my solution is negative 1, 3. All right, let's try another one. Now, there may be a time where you really, neither equation is easy to get a variable alone, so you just pick one and get it alone. Does that make sense? Maybe x and y in both equations have coefficients. Then it's hard to get an equation, a variable alone. So you're just going to have to pick any variable and then do this, get it alone, and then do the substituting. So in this case, what would I do to get y alone?
Subtract.
But then I have, so see here it's 2 steps, and then multiply everything by negative 1. And we get y equals 2x, and then we would substitute that into the other equation, not the same equation. Okay? And I personally think it's easier to work in fractions because I'm okay with impropers. So I generally, why is this still looking the way it does? Okay, so let's take a word problem. Chatty phone charges flat monthly fee of $20 plus 8 cents a minute. Telco charges $14 plus 10 cents a minute. Okay, when do they charge the same? What are my unknowns?
When they charge the same.
No, what are my unknowns? What? Minutes and, there's no months here. Oh, minutes and charges. Charges. What depends on the other? Right, so charge, if that's the depender, becomes the Y. Okay? The depender is always the Y. And X represents minutes. Okay? So now let's build our equation. Chatty phone charges a flat monthly fee of $20. See, monthly, it's not changing. It's always going to be 20. And 8 cents a minute. What would that equation look like?
X equals 20.
No. Minutes equals?
Yeah, no. Y equals.
The charges equal.
20 plus 8x.
Yeah, do you see how that is? It's like a base fee. The charges, we're going to finish this. The charges equal the base fee, the monthly fee, plus 8 cents per minute. Okay, what would the other equation, what would the other equation be? Go.
Y equals 14 plus 10x.
Good. Not 10x, 0.1x. Can you please refrain from zipping? Thank you. Okay, so we have an actual word problem.
Attention, students. The library will be closed during nutrition and lunch for the rest of the week.
So I can substitute for Y.
And lunch during the rest of the week.
I substitute in. I personally would clear the fraction. My PowerPoint is not. They're just working in decimal. I mean, I would clear the decimal. And then we solve for X, get X alone. Whoops, oh my gosh, look what happened there. I solve for X, hold on. Solve for X, I get X alone, okay? X equals 300, and it means at 300 minutes they charge the same. We could then find out the charge if they ask that. Does that make sense? All right, that's the recording.